to finish off, we'll go through this last example, so that hopefully we got this nailed down before we move on next week. So, last example. We've got a mixture of ohms and kiloohms here that we need to be careful with. Okay, where do we start? Hi, where have you started? Yeah, so what you've done to me is you're going to calculate just that bit. Going to parallel those two together. So how have you done that? That's R4 and R5 parallel together. Product of a sum. So R4, R5 over R4 plus R5. Values are doesn't matter, but where yeah, as long as you remember that your answer's in kiloohms, because they're kiloohms. Yep. So 1 times 4 over 1 plus 4. Yep. Okay. Connor, next bit. Yep. So you can look at bringing all of that bit together. Yeah. R3, 4, 5 is equal to R3 plus R4, 5, yeah, 3,200 plus 800, it's not always the case, but in this particular answer, particular problem, probably best to convert your kiloohms to ohms, and then right at the end you can go back again. Yeah. Or well, you could convert your ohmic ones to kiloohms, use 0.27 kiloohms if you wanted, but best to go to one or the other and then decide on kiloohms or ohms at the end. All right. Yeah. So that's that bit. So now we got the total of all that bit circled in red there. Yeah. Next bit. Okay, yeah, you can do. So you're going to do those two together. Yeah. 9 is R8 plus R9. 300R plus 270 is 570 ohms. Yep. Next. Yeah, I can't remember. What's your name? Sorry. Jake. Sorry, Jake. Okay. But so looking at what we've already done, and I'm telling you, what would you do next? There's only one thing you can do now. Which, here? Remember, this blue bit now is a single resistor. Yeah. And then that blue bit and that resistor has now become a single resistor in there. So what we're looking to do is bring in that R2 up the top there by paralleling that, the combination there, together. Yeah. It's getting a bit muddled now with all them circles on the diagram. We're doing, effectively, it's R2, 3, 4, 5, which is, it's R2 in parallel with R3, 4, 5. Like that. Yeah. And that's how, by the way, this is how I would, if you had this question in your assignment, this is how I'd expect it to be laid out, for you to put the formula down and then put the numbers in and then say what the answer is. So R2 is 5,000 times 345, which is 4,000, and over the two added together, 9,000. The answer to that is 2,222 ohms. We won't worry about the 0.2 reoccurring bit. It's not very much in the scheme of things. Okay. Yeah. So what we've done now, we've effectively combined together all of our 2, 3, 4 and 5 to one resistance. So the next bit, all of that bit there now, is one resistor. So we can just add it to this one, which is R6. No, not yet. Because that and that, all of that together and that in series are in parallel with these two. Yeah. So what we can do now is R2, 3, 4, 5, 6 is equal to R2, 3, 4, 5 plus R6, 2, 2, 2, 2 plus 3,600 equals 5,822. Yeah. Ohms. Okay. Might be worth us just showing what our circuit is now. It now is R1, which is 6K3. All of that bit in the middle there is R2, 3, 4, 5, 6, which is 5,822 ohms. There's another resistor there, is that R8. R7, 3K9. And these two are in parallel with, yeah, is that go in here, doesn't it? What these? And that's R89, which was 570. So that's what we've reduced down to so far. This bit is all those other calculations combining 1, 2, 3, 4, 5 resistors together into one. It's now in parallel with these two resistors into one. So if we do that parallel bit there, we can then add the result of that to these two. We've got the final answer. So R 2, 3, 4, 5, 6, 8, 9 is equal to 5822 times 570 over 5822 plus 570. Someone will tell me the answer. 520 ohms. Okay, does that look right with the parallel rule that it's going to be smaller than the smallest one? Yes. Therefore, RT is the R1 plus R 2, 3, 4, 5, 6, 8, 9 plus R7. That's 6300 plus 520 plus 3900. Have I got that right? And that comes to yep. So that's a bit long-winded, but if you're careful, step by step, you gradually break that circuit down into more